Hello everyone, today we'll talk about the problem word break 2. We're given a string and we have to split that string into valid words. And valid words are given as a list of words, word dict. And we have to return all the possible ways of splitting the original string into words from the dictionary. Now this is another problem in a series of recent LeetCode dailies that has the same underlying idea. We can just backtrack, generate all the solutions, and that's it. So just at any point decide whether or not we take it to the solution or not take it, avoid creating any solution that's bad, and that is all that we need to do in this problem. Now before we look at the code, because the code is very similar to the previous codes, and the only thing that we have to keep in mind here is that while the original word is small, it has to be for backtracking, and the words in our dictionary are also small, because they have to be small in order to fit within our original word. The dictionary can be of size at most 1000, which is not that little, and we might have to do something about having a quick lookup whether or not a given word, candidate word, exists in our dictionary. So in this solution we'll just use a set. Because those words are short, then it'll be simple to check if a given word exists in this set. Because it'll be simple to hash this short string to check it. If those words were longer, then of course that wouldn't be a good solution. But here we can use a set to have a quick lookup for membership, and that's all that we need to deal with this 1000 issue. The code is very similar to the few previous dailies. So we will generate current solution and a list of all solutions. We'll have a recursive function that we run on the original string first, and it'll recurse on itself to generate all the possible solutions. Now, if there are no more letters left to use, then that means that we have created the correct split, so we add it to the result. The task asks us to write it as adding spaces to the original string, so we will just join all the pieces by spaces, so that's how we do it in Python. And the crux of the solution is just to, for every length from 1 to however many we want, we will split the string into the first L characters and the rest. We want those first L characters, which we call head here, to be a possible word, so if they are not in words, then we just continue. Otherwise, it's a possible word, so it might be a part of some possible splits. So we just add it to the currently created result, afterwards remembering to pop it back, and we recurse on the remaining part. And we do that for every possible length, and that will generate all the possible splits. One last note, if we had even more words in the dictionary, then it will possibly become worthwhile to use a different structure to check for membership. And one structure that's pretty nice for it is a tree, which is of course written as this. And the idea is very simple. We start with some root node that is no letter, and for every node we have children corresponding to all the possible letters. And we also mark a node if that node is the end of some word in our list of words. And then every word is represented in our structure as a path from the root to a marked node. So for instance, we can have a root, and then we can have the A, B, A, and this node is marked, which means that we had the word ABA within our list of words. This would be also a word, let's say BA. And then if we had the word AB, then we just add, we mark it here. And if we had the word AC, we go AC, we mark it here, and so on. And you can see that it's very simple, that even if our dictionary has a lot of words, but all those words are short, then it's very easy to see if we have a given word in our dictionary, because we just have to go down the corresponding, to a corresponding child. We have to do that at most as many times as the length of the word that we want to check. So if all the words are length at most 10, but there is a lot of them, or perhaps if they were length at most 20, and then there could be a lot of them, then we just go down at most 20 steps to either see that we are indeed in a marked node, so that this word exists in our dictionary. Otherwise, it's not a marked node, or the node doesn't exist at some point, which means that the word was not in our dictionary. So that is a very useful structure, very simple structure to reason about and to implement. It's not necessary, we can just use a set in this case, or some other solution, but still, It's nice to know it.